All right. Welcome to the Pelican computer case. Um, for this, just as a grand overview, what we're trying to do is to create a computer that is A, waterproof, and B, we can take out on site. We've had previous issues with using laptops as sometimes the dongles have connectivity issues and we actually lose connection to the submarine while it's in the water, which isn't ideal. So there was a wish to create a computer case that lets us integrate all the components that we need, including an Ethernet switch, which I'll come to more later, as well as a kill switch, and all sorts of systems. And that be integrated inside a Pelican computer case or a Pelican case that allows it to be waterproof, easy to transport, and just to have everything as one unit. Now, just as a brief overview, this is what a Pelican case looks like. Um, it's basically just a big waterproof box. Obviously, we'll probably be using a knockoff version of this. We don't need to use the original Pelican as they can be quite expensive, but they come in all sorts of shapes and sizes. And here someone has already integrated technology into it. We'll be doing something similar, although I want the connectors to be fully on the inside so we don't have to worry about waterproofing the connectors. Now, if we look at the outline of what we are actually designing into the case, which is more of our system part, we'll be having a Raspberry Pi 5 as our main computer, and this might change, but I'm pretty sure that that's what our software lead wanted. Um, Connected to that, obviously, we'll have a keyboard, a mouse. I don't know yet if we should do wireless or we should do wired, and I definitely want them to be removable from the case, so it's just easier to work on. Also, as a display, we'll be using a 13.3-inch touchscreen display, which should give us a large enough display to actually work with, and also interact with. Then all of that will be powered through the power distribution board. That is the same board we're using in the submarine right now. That is already pre-designed. We don't have to do that. Um, and that can take anywhere from 12 to 16.8 volts, which is two S batteries in series. Um, and then output 5 volts or 12 volts, depending on how we need it. Now, for the peripherals themselves, well, first of all, we'll be powering them from two of our batteries that we're also using in the submarine itself, which means that we'll be running at 4S 8,200 milliamp hours, which gives us a nominal voltage of around 16 volts. Those will then be connected to a voltage indicator. I don't know if you can see that properly. That will just make sure that we don't undervolt the batteries and make sure that we actually keep the cells balanced. That's something we may need to design, but we could also just use the indicators we're using right now in the submarine, which are bad for the submarine because we can't always read them out. But once we use them in the computer, obviously we will be able to read them out continuously. So maybe that's the solution we can go for. Then we will connect both these batteries, as well as a 5.5 millimeter DC 12-volt barrel jack input, to a continuous switching module, which we will have to design ourselves. And basically, the point of that module is to switch between battery power and wall power without any interrupt so that the computer doesn't actually shut down. Then we also want to be able to switch between those. So we will have a switch to be able to choose which one we want to draw the current from, as well as a power switch that just generally powers on the computer case. Then we want a submarine power case. Sorry, we want an Ethernet switch power case because these tend to consume power. Um, that we can turn the Ethernet switch off and on with, as well as a 12-volt switch for this 12-volt output that will be either then powered through the batteries, depending on how the rest of the system is powered. I'll come more to that in a second. We also want obviously an emergency stop button, which will absolutely kill the submarine. So it'll tell it to completely shut down, and then as it's neutrally buoyant or positively buoyant, it will rise by itself. And then we want an arm switch, which basically allows us to turn on and off the submarine, but not completely. So it's just basically if the submarine is armed, it is able to control its motors and spin up its motors. If it's disarmed, it is unable to do so. For the Ethernet switch, that is basically a module. If you don't know what an Ethernet switch is, it's basically allows you to put multiple Ethernet peripherals onto one network. So the Raspberry Pi would plug into this, and then the submarine would plug into this. And that would just allow them to connect. Now, what we can also do then is plug in any other peripherals we have. So for example, if we start building pingers that connect through Ethernet, we can then connect these here as well and control them all centrally from our basically central hub. Um Then what did I miss? Oh, the 12-volt output here and the HDMI out, those are both for a pair of first-person view goggles that I have. And they would allow us to actually see what the submarine is seeing. Um, so for that, we have an HDMI output here and a 5.5 millimeter barrel jack, 12-volt output. Lastly, we will need a fan in the computer case because I think as we are packing it into a waterproof case, um, the air will get trapped in here and will just heat up. So what I want to do is pass air from over here down through the case, through the electronics, and then out here where all the peripherals are. That's something the mech team is more going to be worried about, but right now we just need to get a basic idea of what we're doing. Then, in terms of the design review, there's a few questions I want answered. First of all, is how we can actually build this continuous switching module. I also wanted to include temperature sensor and all other sensors just will keep this computer safe. Although for that we might be able to use just the temperature sensor on the Raspberry Pi. Um, then I wanted to, sorry, it is quite early, but I wanted to figure out how we are going to interface. So if we have any other ideas of what we could be putting here, this is just a brief outline of what I thought should go there. But obviously, if you have any other peripherals that we need, feel free to state those and to do some research on those, as well as on if we will like what specific components, especially for the touchscreen display, keyboard and mouse, what we're doing with those. Um, just get an outline of specific components that we're going to be using, how much power they draw, how much, what voltage they need, how much current they need, obviously. And then there was one more thing that I'm just forgetting, but I'm gonna add that to the chat. And yeah, I'm looking forward to work with you guys. As a quick heads up, I'm gonna be your lead for this project right now. That will later change to one of you guys, but just so we can get started, I will take over. And yeah.